Welcome to Chapter 3, where we are going to cover polynomials part 2. What we're going to start off learning today is long division. Now you might remember long division from elementary school. We're going to be doing long division with equations. But it is very closely linked to what you did in elementary school. So we're going to start with a long division problem from elementary school and then apply that to long division with equations. So let's do 20,693 divided by 12. So if you remember from elementary school, what you would do is you would start by saying 12 goes into 20 how many times? Well, 1. Then you would multiply 1 times 12 and write it down here. Next, you would subtract, so 20 minus 12 is 8. Then you'd bring down your next number and do it all over again. So 12 goes into 86 how many times? Well, 7. 12 times 7, so we multiply it in, gives me 84. Then we subtract 86 minus 84 is 2. Bring down your next one. Do it all over again. 12 goes into 29. How many times? Twice. Multiply 12 times 2 is 24. Then subtract 29 minus 24 is 5. Bring down your 3. 12 goes into 53. How many times? 4. Then we multiply. 12 times 4 is 48. Then we subtract. 53 minus 48 should be 5. And this 5, if you remember from elementary school, is your remainder. So you would write your answer, 1,724, remainder 5. Some of you might have had elementary school teachers that had you write your answer as a mixed number. This is helpful because this is how we'll write our answer when we do long division with equations in just a minute. When we write it as a mixed number, you would still have your answer, 1,724. Here, I'll color code this. But you write your remainder as a fraction, where the numerator of your fraction is your remainder, and your denominator is what you divided by. So that is another way of writing your answer. They're both valid, but this one right here is how we'll write our equation answers when they have remainders. So that's the one that's more applicable for today. Now that we've reviewed multiplying from elementary, let's go back up to example number 2 and review division for equations. Sorry, I think I said multiplying. I meant division. So we have x plus 4 divided by x squared minus 5x minus 36. And I think I said that backwards. X squared minus 5x minus 36 divided by x plus 4. There we go. Now, the first step is the most different. Because if you remember down here, the first step was how many times does 12 go into 20? But if we tried to do the same thing here, it doesn't make a whole lot of sense. How many times does x plus 4 go into x squared? That doesn't really work. So the first step is the most different. But here's a shortcut to help you know it. The first step only deals with the first part of your quotient rule. So right here I have x plus 4. I actually am going to ignore the plus 4 for just a little bit and only use the x. and I'm going to think x times what is going to equal the first part in the division. So once again, I'm ignoring the rest of this and only focusing on the x squared, the orange part. And now I read this. X times what equals x squared? Well, x times x equals x squared. And whatever you write in that second parenthesis, that's what goes on top. Now notice that I'm lining up my columns. This right here is the x squared column. This is the x column. This is the numbers column. Since my answer was an x, I'm putting it in the x column. Now I'm going to distribute. Now, let's go back to this one from elementary. The next step that you did here was multiplying your answer to get this number. So 1 times 12 is 12. 7 times 12 is 84. 2 times 12 is 24. So the next step is multiplying. But if we're talking equations, when we say the word multiply, what we really mean is distribute. So we're going to distribute this x into everything in front. I don't ignore the 4 anymore. I'm going to look at both of them. So I'm distributing it into everything. So x times x is x squared. X times 4 is a positive 4x. So there's my next step. Now, just like we did down here, the next step is subtracting. But once again, with equations, subtracting is going to be a little different. So if you remember, when you got problems like this last chapter, the first step when you got problems like this was that you needed to distribute the negative. So that it was x squared plus 5 minus x plus 4. Well, same thing down here. If I'm subtracting, I can't just subtract the first one. I need to distribute that negative to everything. Shortcut way to remember this is change all the signs. So I change this sign to a negative, change that sign to a negative. And now I combine them. So x squared minus x squared, those cancel. Which, by the way, if you've done it right, that first column should always cancel. If they don't, you've done something wrong. Then I have minus 5x minus 4x, which is a negative 9x. Now I'm going to do all the steps over again. So my first step is the multiplying. But my orange one is different now. Oops, sorry, I forgot to bring down my negative 36. There we go. So once again, I only care about the first ones. So only the x, only the negative 9x. And I think x times what is negative 9x? Well, that would be a negative 9. So that's what I write up here. Next step, distribute that negative 9 into everything. So x times negative 9 is negative 9x. 4 times negative 9 is negative 36. Next, subtract or change all the signs. So I'm going to change that negative to a positive, change that negative to a positive. Combine them, negative 9x plus 9x cancels, just like it's supposed to. Negative 36 plus 36 is 0. So this problem happens to not have any remainder at all. So since it doesn't have a remainder, our answer is just x minus 9. In the next video, we'll go through and do an example that does have a remainder.